In this question, n small conducting liquid droplets, each of the radius of small r, are charged to a potential V each. These droplets are form a single large drop without any charge leakage. Find the potential of the large drop. So let's understand this question with a figure. As you see in this figure, according to the question, we have n number of small conducting liquid droplets, and these all liquid droplets has, let's take the charge q, and the total number of the droplets are n. N is our number of liquid droplets. So when we combine all these droplets into a single large droplet, so then the radius will become capital R. So we have to find what is the potential of this large sphere. So to solve the question, we need to understand 2 points. First is the conservation of volume, and second is conservation of charge. So here, conservation of volume means the total volume of this large drop, let's assume it as a V dash, it is equal to the sum of the individual volume of each of the liquid droplets. It means it is equal to V1 plus V2 plus V3 till n. And as all the small liquids has same volume, so it can be also written as V dash is equal to number of droplets into the volume of each droplets. So this is our conservation of volume. Next is conservation of charge. Same logic is applied in the conservation of charge. If the charge of one of the small droplet is a small q, so the total charge will be of this system will be n into a small q. So as these total charges are combined together and it is present on this large body droplet, so we can say that total charge q is equal to n into a small q. So this is our conservation of charge. It is same as the conservation of volume. Now volume of a sphere, as we know, it is 4 by 3 pi capital R cube is equal to n into 4 by 3 pi a small r cube. Here 4 by 3 pi gets cancelled. R cube is equal to n times a small r cube. So R is equal to n to the power 1 by 3 into R. We are getting the relation of a small r and capital R. But why we need this? Because we know that potential at a point charge, it's equal to k q by r. And in this question, we have to find the potential of this large droplet. So we can say that this potential is equal to k capital Q by r. So as we have to link this capital R to the small r and the capital Q to the small q, so that's what we have to go with the conservation of volume and the conservation of charges. So now if we have to find the potential of large droplet, so we can write it as k capital Q by capital R. And capital Q relation is n into a small q. This is the relation of capital Q. So if we substitute it here, n into a small q by capital R is n to the power 1 by 3 into R. After solving, we can say that it is equal to n to the power 2 by 3 into k a small q by R. So small q by R, this point, is nothing but the potential of a small charge drop. So we can also write it as potential of large droplet is equal to n to the power 2 by 3 into potential of a small droplet. So this is the answer of this question. V is equal to, or V dash is equal to n to the power 2 by 3 into